Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
I'm Vance. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
That was pretty good, brother. You all glad that's over with?
Yeah.
Yeah, so are we. We're glad you actually took care of that for us right there. So, Vance, where do you go to school and what grade are you in?
I go to Reagan Elementary and I'm in 4th grade.
How is 4th grade?
It's pretty fun.
It's pretty fun. So what do you think, if somebody's in 2nd or 3rd grade and they said, hey, Vance, you said that 4th grade's pretty fun. What's something fun about it?
You get to do a lot of other things that younger kids in the primary grades don't get to do. Like you get to go to music class a lot more, and also you do like harder math.
Okay, good. So you like going to music?
Yeah.
Do you play an instrument or you just like music overall? Because I don't know.
So I play piano.
Okay. So you're already going on an instrument.
Yeah, I'm not at school, but I do it at home.
Right, because I think you have to be in 5th grade to start at school, correct?
Yeah, I see 4th graders play like string, I think, or like violin.
Oh, okay. And you like doing the more difficult math?
Yeah.
So have you done anything that's really difficult yet this year?
A few things, but not very many.
Not very many? How about we do some difficult math today?
Okay.
Ooh, there you go. That's what I like to hear. Okay, that's what he's up for that. All right. So how about, here's going to be our first difficult math problem of the day. We'll see how difficult it is. I don't know, because we have to take a look at it together. It's our social media problem of the day. Are you ready? Mm-hmm. All right, let's take a look at it right now. So it says, problem of the day, add these Roman numerals. So, first of all, do you have any idea what Roman numerals are?
Oh, I get it now.
Oh, I get it. Yeah, see that now once you see that, right? So
Yeah.
what do you think of when you see that?
An X is 10, and then an I is a 1.
Okay, that's good, because there's some students out there going, I've never seen Roman numerals before, or they may have seen them, but they're not quite sure how they work or what they stand for. So we know an X is 10, and...
So XX, that's 20,
Okay.
plus 3 I's, that's 3. 23 plus 2 X's, that's 10. And then a V is 5 or 4?
Are you asking me or telling me?
I don't know. I think it's 5. And then add a 1. So then 26.
All right, so if you think the V is a 5, then that would be 26.
Yeah.
So, and you thought it could be a 4 or it could be something else, right?
Yeah.
So when you think about the basic numbers and letters for Roman numerals, you always start off with the I, which is a 1.
Yeah.
And you had that correct. Now, if you went to the next symbol, which would be a V,
Yeah.
and then we have the X. Those are the first 3 symbols, I, V, and X. So I is 1, we know X is 10. So what do you think the V would be?
4 or 5.
Okay, so why do you think 4 or 5?
Because on a clock, if you look, there's 1, there's 2, and then there's 3, 4, 5, and then on 5 I think I see a V. It's just a V.
Okay, well, the V is a 5 in Roman numerals.
Okay.
Okay, so let's take a look and see once again. So they want you to add these.
Okay.
So the first set added up to what again?
23,
Okay, and the second set?
26.
And what would those add up together?
49.
Okay, so 49. So now we have to think, do we put 4 X's in a row to get 40? Or is there another way to write that? Because I see some other letters up there. We have an L.
An L?
So an L is up there other than the X's and I's and V's, right? Because there's no V's underneath in the answer. It's just X's and I's. Well, there is a V in A. But then we have an L in a couple of them. So any idea what the L is?
Maybe it's gonna be 20?
Could be. That's a very good guess to make 20. But we know that we can put two X's together to make 20.
Yes.
The L, what do you think would be the next whole round number? So we're going 1, 5, 10,
And then one.
and we know a C is going to be 50, or 100, I mean.
A C's 100?
C is 100.
Okay.
So we're going to go
1,
5,
5,
10,
10.
something 100.
1, 5, 10. Go another 5, 15?
Almost. But we're going to multiply by 5, so we're going to make it a 50.
Oh.
So the L is 50.
Okay, so we're gonna cross out every single one with an L then,
Why is that?
because we have 49.
Well, that's good thinking right there, right? Because if an L is 50 and we know we only have 49, we can't go past 50.
Yeah.
Now, if we have an X in front of the L, what do you think that is?
That would be 6. Yeah, 60.
Okay. If it went LX, it would be 60.
Yeah.
If it's XL, it means 10 taken away from 50.
Oh, really?
Yeah. Here's one way to remember this, all right? And I don't know if many people are going to catch on to this, all right? And I'm sure there are thousands of other ways to remember the Roman numerals, okay? But XL, most men, when they become 40, move into an XL as far as the size. See, I heard laughing back there, right? And because they get it. That's why they're laughing, right? So an X before the L means you're taking 10 away from the 50, which is 40. Okay? What if I had VL?
VL, V's worth 5, and then L you take away.
So we take away 5 from
5 from,
the 50,
Yeah.
right? VL.
so
Right.
45.
Right. Or we could go the 4 X's and the 5 after, but I think when we're doing this 50, that's why the L is 4. All right? So XL is going to be 40. All right? So let's take a look at our options again. So what would
So-
A equal?
XL, that's 40.
Right?
V is 5,
Right.
45, and add 2, that's 47.
Good. Not the 49 we need.
Nope.
All right. What about B?
B is XXIX.
Now remember, the I before the X is going to take 1 away from the X.
So 1x equals 10. Another is 20. The I subtract from the x is 9. So 29.
Good. Excellent. You're catching on to this, right? Okay. So now 29 we know isn't right. So what about C?
C is XL, so then that's 40. And then you have the I and then the X. And then, so X and L, that's 40.
Right.
Add 1 to 40. And then you take away 1 from 10. And
You've
then
got it.
You got
Keep going.
9.
Good.
And that's 49.
Good. So we think C could be the answer.
Yeah.
But let's take a look at D.
D is XXXXIX.
Okay. So the 4 X's make,
40.
okay.
And then take away 1 from the x, and then take away 1 from that x, and then you get 9. So 49.
Okay. But now we have 2 of them that say 49. So which one is correct? Because we're not going to have 4 X's. Instead of saying 4 X's in a row, we're going to take 10 away from a 50. So which one do you think is correct? Because 2 of those actually say 49, but one's written correctly, one's incorrect.
I think that C is written correctly.
You do think that C is written correctly. I'm
Yes.
glad you took a pause because that does take a little bit of getting used to if you've never seen Roman numerals and dealt with them like that before, right?
Yeah, because I seen them on a clock like 1 through 12, but
Okay.
then I don't get it up. So I think C is written correctly.
The next time you see a clock with Roman numerals, I want you to look at the 9 and see what it is. All right, because you're probably thinking 5 and then 4 I's, but it's going to be the I before the X. So that's going to be the 9. That way you kind of remember we're going to take 1 away from that bigger number.
So it's going to be I and then X for
That's
9.
it. So you take a look at that next time you think about it, all right? All right, let's see if you are correct on this one, C. There you go, dude, 49. All right, so now you got a little taste of the Roman numerals, right?
Yep.
All right, and that is what they use when they are doing Super Bowls,
Really?
right? You've seen the Super Bowl before, right?
Yeah.
Okay, so right now we're in Super Bowl, I think like 63 or 64 is coming up, right? So when they start advertising for the Super Bowl at the end of football season, you're going to see Super Bowl and you're going to see Roman numerals. You now are going to have a better idea what those mean now.
Yep.
All right, very good. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to deal with the NFL once again. So we were talking about Roman numerals. I was speaking with Vance a little earlier, and he said that his favorite team is the Kansas City Chiefs. And Vance said that he likes the Chiefs. And Vance, once again, why did you like the Chiefs?
Because they win.
They win a lot, right? So they do. They certainly do win a lot. They've won the last couple of Super Bowls. And it's amazing how they win some of their games. But one of the interesting facts that we found out about the NFL is how many Uncrustables they eat. So before I get to this, Vance, do you eat Uncrustables?
I have before, but I don't really eat them anymore.
You don't eat them anymore?
No.
Now that you're in 4th grade because you're a little older or something?
No, I like eating normal sandwiches.
I'm only kidding you. So, Cindy, do you eat Uncrustables?
No.
No? All right. Well, I know a lot of students.
No.
Who does?
I said I have in the past.
Well, there you go. You know what? I think this is one of those delicacies I don't think I've ever had, because when we were growing up, there was no such thing as Uncrustables. You eat the whole sandwich. All right? There was no such thing as Uncrustables. Kids would just tear the crust off and toss it or whatever. So anyway, so we're going to talk about Uncrustables today. So the NFL eats quite a bit of Uncrustables. So the Athletic talks about how many Uncrustables each team eats. So Vance said that he likes the Kansas City Chiefs because they win a lot. Funny, the Kansas City Chiefs only eat 80 Uncrustables a day.
Really?
All right? Now, that's more than some of the other teams, but not anywhere near some of these others. So 80 for the year is what it is, right? So Denver eats 700 for the entire year. Now, this is not every NFL team, because some NFL teams do not allow Uncrustables for one reason or another. Or they make their own peanut butter and jelly. They know the benefits of it, but they don't buy Uncrustables, they just make them. And what we're doing is, instead of representing 700 different Uncrustables, they made a graphic where each Uncrustable represents 10. So that when you see down here with New Orleans, we've got 5 Uncrustables. Each Uncrustable is equal to 10. Maybe your team's up there, perhaps it's not. So the next, we want to take a look at why do NFL players eat Uncrustables. So there actually is quite a bit of nutrition that goes into an Uncrustable because of the peanut butter and the jelly and the sandwich. So we're taking a look at the carbohydrates, right? And that's 10% of the need for an average person. So they need that for energy. Protein helps repair muscles that might get damaged during workouts. Fat to absorb nutrients. So that you can see each of these are listed. You've got total fats, carbohydrates, and protein. Obviously, when you're working out, you want a lot more protein. This is all based on a 2,000 calorie per day diet for an average adult. So we can see, now before we go on to the next graphic, we can see that 2 of these are highlighted. So an NFL player needs more calories than an average adult. For an average adult that is looking to stay on the healthier side, if you want to know if something is worth eating, you want to take the carbohydrates and the fiber. You divide the 2 numbers, the number of grams, the percents you don't need to worry about. Simply take the 2 numbers and divide them. If we take 28 and divide it by 2, we have 14. If the number is 5 or less, it's good for you, it's worth eating as far as a healthy lifestyle goes. Now this is 14. Not that it's bad, but for their intake and what they need, it's going to satisfy their requirements. But if you're just a person, you're trying to stay healthy, you're like, oh, you know what, I want an Uncrustable. Well, the difference here is 14. It's higher than 5. So obviously you can eat it, but you're going to have to do a lot more work to get rid of that you're eating. So anyway, just a little side thing for an average person that's trying to stay a little bit healthier than an NFL person. Our final one, we can see that the consumption, so we've got New Orleans down here at 50, we've got Chicago at 100, and Denver at 700. So we're kind of taking a look at the whole gamut of the Uncrustables here. So how many more times do the Broncos at 700 eat Uncrustables over the Bears and the Saints? Well, we can start with the Broncos eat 700. We know that Chicago, the Bears, eat 100, and we can see that the Saints eat 50. So we want to know how many more times do the Broncos eat Uncrustables over the Bears and the Saints? Well, let's just take the Saints and the Bears first of all right? So if they're eating 50 and they're eating 100, they're eating 2 times more than the Saints. If the Broncos are eating 700 compared to their 100, they're eating 7 times more than the Bears. So if we want to compare the Broncos to the Bears, they're eating 7 times more. The Bears to the Saints, it's twice as much. But if we want to go from the Broncos to the Saints, we can simply multiply these two, and that is 14 times more. Or if we did 14 times 50, we would get to 700. You can check it, you go 700 divided by the 50, you're also going to get 14 times. That, the Uncrustables, whether you like them or not, is today's Math in the News. We'll be back with a little bit more right after this.
My name is Tanvi Mahajan and I'm currently in 5th grade and I go to Ronald Reagan Elementary. Today we're going to solve algebra. So right here we have 18 minus 4x equals 5x. There's something in common with these equations. We have like 2 x's right here. So what we can simply do is we can move this 4x right here, which will equal to 18 equals 9x, because when you move the 4x over to this side, the negative becomes positive. And so what we can do is we can simply divide this by 9. So that'd be 2 equals x. Or you can simply write x equals 2. And if we wanted to check this again, what we would do is we would multiply x from this equation by 2. So 18 minus 8 is equal to 10. 18 minus 8 is equal to 10. Thank you.
Nicely done, always ready to solve for the X. Well, in studio we have Vance, a 4th grade student from Reagan Elementary. And have you been at Reagan for a long time, or are you a relatively new student there?
I've been there like for a long time, for like 5 years.
Forever?
Yeah.
Not forever, but I mean forever as far as schooling goes.
Yeah, so I've been there TK through 4th grade.
All right. And what is one of your most memorable things about Reagan so far?
I'm used to all the kids there, and like I'm used to the playground and all the teachers.
Okay, good. So you're pretty happy with the way Reagan is going?
Yeah, and I know like where every direction is. I know where I have to go.
Okay, well that's good, because guess what's going to happen when you get to junior high school?
I'm not going to know because I'm going to be new to junior high.
Yeah, right. So I think they have, I'm pretty sure they have an orientation day for you, right? And Cindy works at one of the junior highs, at Warren Junior High, and they do have an orientation day, right? At the end of the regular school year before they come, or is it at the beginning of the school year?
Well, they have a 6th grade orientation, but they also have a beginning of the school year
Right,
orientation.
because
So
I
they
think
kind of
at
have
the
both.
end of the year, so when you're in 6th grade, I think at the end of the year, like in May or something, they'll bring you over to your junior high school and they'll kind of talk to you about the expectations.
But the
You
more
don't really
walking
see a lot of
around
it
and stuff
until
is
you
at the
go
beginning
at
of
the
the school
beginning of the
year.
But then you get to take electives and things like that. And I want you to say, the first elective I want is the most difficult math course you have. You do something like that?
What?
Yeah, that's right. You ready to do some math? Right now, you ready?
Yeah.
All right, get on over to the board, young man. All right, so right now you said that you were working on division problems in 4th grade.
Yes.
So what I'd like you to do is just put up an example of a division problem that you're working on in class, and explain to Cindy how you would approach solving that problem.
Okay, so for example, you can do 4 going into 289. So 4 goes into 28. No, so the 4 can't go into the 2, so you cross that out with your x. 4 can go into 28 7 times. Get your 28 down there, subtract it, and you got 0. Now bring down your 9 because 4 can't go into 0, and 4 can go into 9 2 times, which gives you 8. Now subtract that, you get 1. So you got a remainder of 1.
Okay, so 72 remainder 1.
Yep. And to check your answer, you would have to get 288. And then you'd add 1 more with your remainder. So 72 times 4. So 8, and then 2, and then 8. So 288, add your remainder, and you got 289. So
Nice.
that's your answer.
All right.
Nicely done. So here's what I'm going to do. I'm going to toss you a different type of problem. So go ahead and we'll erase the board. I think Cindy can do that for you real quick.
Okay.
We can just add a page down at the bottom, all the way over to the right.
Oh,
Just hit that plus.
right down there, right?
You there? All right.
And hit that plus sign one more time. There we go.
There we go.
Okay.
All right. So let's put your division house up there, your division symbol like you had up there before. And outside of it, let's put 3.
Okay.
And on the inside, let's put 23.45. So
2.3.
23.45.
2.45.
Now explain to Cindy how you think you would go about that problem.
But I first try going 3 into 23.
So you're going to start it off the same way. So
Okay.
3
So-
and 3 go into 2. All right.
And then 3 can't, so 3 times 8 is 24, so that's too much. And then 3 times 7 is 21, so 7.
Okay, so 7
And then
fits.
21, and subtract that, and then you got yourself 2. And then 3 can't go into 2, so then you'd bring down your decimal, and then bring down your 4.
So what you actually do with the decimal,
Okay.
what makes it a little bit different is you bring it straight up into your answer area and then you ignore it. So you're just going to put it right here.
So ignore that
And then you're not
decimal.
even going to have to bring it down here. So it's
Okay.
just 24. So
24.
Let's erase that.
So
Okay, hold on.
3 goes into 24 8 times, we know that now. And 3 times 8 is 24. Now subtract that and you got yourself 0.
Okay.
And there's also 5, so 3 can't go into 0, so you bring down 5. And 3 can only go into 5 one time because 3 times 2 is 6, so we can put a 3 down here, subtract that, and you get 2, so then 7.81
So instead of-
2.
All right,
So when you-
erase your remainder 2.
Yeah.
We're going to add to the rest of that problem here.
Okay, so when you work with decimals,
So after the 5, right. So
Okay.
put a,
when
Go
you,
ahead, Cindy.
Yeah, when you work with decimals, you can no longer write remainders. It's a little bit different because a decimal, like you think of like pennies and quarters and stuff, it's like part of something. So it kind of is where your remainder gets included. And so what you do, if you still have a remainder, is you add a 0 to bring down. So you
0?
add another 0 here, and
Bring it
then you
down?
can bring it down. And so now you keep dividing.
Okay.
So let's extend that out there.
So 3 can go into 20 6 times.
Okay.
And then get an 18, subtract, let's do this, 0, and then you got it a 10 and then 2.
All right, so we got remainder 2 again. So he's really throwing something at you here. So if you add another 0, what's going to happen?
You're going to get another 20. So you do another 6.
And then you're going to get the same remainder, and then you're going to get the same answer over and over, right?
Right, so
Will it
this is
ever
going to be
end?
new for him, Cindy, but show him how
Right,
to stop.
so this
that we
is
don't
new,
keep
that's what I'm
going
saying.
forever.
So when it keeps going and it starts repeating something as your answer and you're not gonna be able to make it stop, you write it as every number you see up to the fact that this is repeating twice, you can write it once and you put a bar over the top of it, which tells us that that number repeats.
Okay.
So then it would look like that as your final answer.
And that way, the 6 is going to keep repeating. Does that make sense?
Yeah.
Yeah.
Because every time you keep multiplying 3 by 6, you're going to keep getting 18, you're going to keep bringing down the 2. And it's going to go on forever and ever and ever. So instead of doing that forever, you just put 7.816. The bar is only over the 6 because that's the only number that keeps repeating. So it would be a repeating decimal with the 6.
Okay.
So that's something a little new for you. So you are going to get to that at some point.
Yeah, you will.
Probably not right this second in 4th grade, but that is going to be coming up, all right? Very good. For a great problem right there today, you've got yourself a pass to go see the Bakersfield Condors. Hockey season in full swing, so congratulations on that. Hopefully you have an opportunity to go see the Condors sometime. We'll be back with more right after this. And once again, Monterey, a great place to visit if you haven't done so recently. And the Harbor Seals, always fun to go check out and learn more about them. In studio, we have Vance, a 4th grade student from Reagan Elementary, doing a little bit of division, but expanding his knowledge a little bit more with the decimals and then repeating decimals and remainders and things like that, right? So pretty interesting how much stuff you can do just off of one problem. You feel pretty good with that?
Yeah.
All right. So I know that you said that you have done some things in the past with prime and composite.
Yeah.
And you're kind of familiar with those numbers, but you could use a little more practice?
Yeah, because a prime number, like if you, you can only multiply it into like like it can only get its own digit.
Okay. So 7.
Yeah, 7 or like 3 or 2.
So 7 would be a prime number.
Yeah.
Why?
Because
That's what I want you to think about. You and Cindy head on over to the board. Cindy, maybe put up 2 headings, prime and composite.
Okay.
Vance, head on over there. You guys can talk a little prime composite numbers. Because you're on the right track with what you're explaining, but you and Cindy are going to go a little further with this.
okay.
Okay. So, tell me what you know so far. I heard a little bit of what you were saying up there, so.
So there's prime numbers can like be 2 times 1 equals 2. Like so, like if you times it by a number, you get its own digit. Like that's what I've learned about prime numbers. And then I don't really know much about composite numbers.
So it's true, okay, I hear what you say if you times it, but what if I did this? Does that make that one prime?
No.
Why not? See if we can
Because
extend your explanation more. Why not? You're right, it's not, but why not? And if you're not sure, that's fine too, just tell me.
I'm not sure.
Okay, so the definition for prime is a number greater than 1, so 1 doesn't count as prime. That's only divisible by itself and 1. So since 4 is also divisible by other numbers, what can you break 4 down into to make it?
You can break 4 down to 2.
2 times 2, right?
Yeah, and 2
So
times
since
2
you can make 4 from something other than 4 and 1, that's
Yeah.
what makes it composite. So composite is basically just the non-prime numbers,
Oh.
and prime is your prime number. So let's put some on here. So I'm just going to erase this part so we can have a little room. Okay, so where would we put the 2?
The 2 would be in prime.
All right. And then 3? Where would that go? All right, here, let me just, so we don't think it's 23. All right, where would 4 go?
Composite.
Okay, because 2 times 2. All right, where would 5 go?
It would go in prime.
Because the only way you can make 5 is 5 times 1. So where would 6 go?
Composite.
Okay, and why?
First of all, 2 is only even number and
Okay.
prime numbers, and then also 3 times 2 is 6.
Yeah, and that's why 2 is the only even number, right? Because all the even numbers can be made with 2 times something.
Yeah.
Yeah. Okay, so where would 7 go?
7 can't be made, so it's in prime.
So then you already told me the even numbers are over there, so,
So
we know where the
8.
8 would go. What about 9?
9 is a prime.
So how can you make 9?
Actually, no,
So
you can
one-
make 9 3 times 3.
There you go. There you go. All right.
And then 10 is
11.
11 is a prime.
Yep, because you can only make it with 11 times 1. So let's just, we already know all the evens. Let's go ahead and skip them and just focus on the odds. So where would 13 go then?
13 can be made by, no, it's a composite. No, you know it's prime.
Okay, good. So 15 would be our, if we know 14 would go there, right? So 15 would go where? Good.
Because 3 times 5 is 15.
All right, so I'm going to let you guys get up to 20, and then we're going to go to
All
a
right.
phone call.
Okay.
So 16 we know would go there. 17, where would that go?
17,
You can always write down here too if you need to.
okay.
Getting squished in there, huh? All right, so we know 18 would go there because it's even. How about 19?
19 will go,
Think of any of your facts, multiplication facts that would make 19? Or is it just 1 times 19?
I think it's just 1 times 19.
It is.
19.
Does that help you understand the definition more?
Yeah, and then 20 goes
Yeah,
here.
there.
All right, there you go. So you've gotten all the way through 20, kind of figured out the prime composite. So if the number is only divisible by 1 in itself, it's prime. All right, and I'm going to quiz you on the number later on. But right now, Cindy, go ahead and clear. Let's make a new page. And right now, we're going to go to the phones with Hargan, a 5th grade student from Bill Williams. How are you today, Hargan?
Good.
All right, so why don't you go ahead and read the math problem that you've got, and you and Cindy are going to work it out. Vance is there for some backup in case you guys need it, all right?
Mm-hmm.
Okay, tell me your problem.
One multiplied by 30.
1 multiplied by 30?
Mm-hmm.
Okay.
And 0.1 multiplied by 30. And 0.01 multiplied by 30.
And you're looking for a pattern, correct?
Yeah.
All right.
Okay, and have you worked with some decimal multiplication yet?
Yeah.
Okay. So go ahead, tell me what's 1 times 30.
30.
Okay. So then for 0.1 times 30, what do you think is going to happen?
It has to be 30 because it's 1.30, I think.
Okay, so it's 1 times 30, and then what happens on multiplying is you count your decimal places. So since it says
Yeah.
0.1, there's only a 1 number that's on the right side of your decimal or in the tens place. So you would move your decimal from the back or the right side of the 30 and make it 3 instead of 30. So you'd move it in between the 3 and the 0.
Yeah.
So what do you think is going to happen when we have 0.0 or 0 And 1/100th, or 0.01 times 30.
It's 30.
Okay, so it starts as 30. And then we need to move the decimal how many places this time?
Like there are no places, it's 1 and multiply by 30.
Right. So can you see what I'm doing or no?
No, I can't.
Okay.
Okay.
So where you're at for the 0.01 times 30, do they already have an answer next to it that says 30?
No.
Is that what you were saying? Okay. So it's 0.01 times 30. What you're going to do is you ignore the decimal and you do 1 times 30, which gives you 30. But then to put the decimal in the correct space, you have to count the numbers after or on the right side of the decimal. So since it's 0.01, the 01 that's on the right side of the decimal, that's 2 spaces or 2 digits. So that tells you that you take your decimal that's at the end of the 30 and you move it left 2 times. So you get 0.30 or 0.30. So you get 30 for 1 times 30, and then 3 or 3.0, you just drop the 0 for 0.1 times 30. And then for 0.01 times 30, it moves 1 more space, so it's 0.3. So each time it's going to move to the left. So if you had another one, you'd move it 1 more time to the left.
Oh, okay.
So hopefully that helps you out, Harrigan. And if you do have an opportunity later on, you can just go to our website, check out the YouTube page for today, take a look at today's show, and you can see that worked out. That way you can visualize it as well. But you and Cindy got through that problem together for a great problem, and for calling in today, Harrigan. You got yourself a pass to Calm. So congratulations on that. Hopefully you have an opportunity to go out with your family and check out some of the animals at Calm. We'll be back with more right after this.
How does energy travel in space? Electromagnetic radiation is one form, and it acts like a wave as it moves at the speed of light. It's how energy from the sun reaches Earth. This type of energy oscillates as it propagates. See? Waves. So why do we care about electromagnetic waves that travel through space? Well, electromagnetism is one of the 4 fundamental forces in nature. That means it affects just about everything. Without it, we wouldn't have electricity or magnetism, 2 aspects of this force. And then there's this. Electromagnetic radiation is classified by the frequency, how many times the wave oscillates in a given amount of time. Waves with different frequencies are useful in different ways. This includes high-frequency waves like gamma or X-rays, and low-frequency radio waves too. And in between are all these other kinds, including visible light. The electromagnetic spectrum is the range of all possible wave frequencies.
Yeah, great phone call right there from Harrigan, and Vance even learned a little bit right there, and he saw that pattern. Vance is a 4th grade student from Moragan Elementary in studio with us today. You ready for another math problem?
Yep.
That's what I want to hear. Over to the board, you guys. So you're going to do number strips. So you need to rearrange the order of the 7 strips so that every row contains a correct mathematical statement. So you have 4 columns of numbers, and you have 3 columns of operation symbols. So what you're going to do is you're going to have a column of numbers, you're going to put a column of operation symbols in between. So it's going to go number, symbol, number, symbol, number, symbol, number. All right? So you and Cindy are going to work together, and you're going to rearrange all those strips so that they make correct mathematical statements.
Okay. You want to just try some and see where we're at and then adjust
So I
from
just
there?
put my finger on the board?
Yeah, I believe they just moved.
So you can move the strips, right?
So maybe we move these over first. It means, whoops. Yeah. Of course I do that. 1 finger up is better. You don't make it change sizes. Okay. Sorry. Okay, let's get some space between them because we know we at least have to. All right, what do you want to put between these?
So,
Shrink these down. Okay, that's pretty good.
You can, on this first strip, 13 is a prime number. 10 is a composite number.
Well, I think we're going like this.
Okay.
So like,
So
for
like
example,
this?
if we went like this,
Oh.
then we would be doing 13 plus 16 and whatever we put here with the like if we just did this, for example, like we just threw them in the order they're in.
Right, so just do that and see what
Okay,
comes up.
See what we got. So what would this side add to?
That side would add to 29.
Okay, and then this is only 3. So we know we can't leave it like that because the two sides have to be equal, you know, because there's an equal sign. All right.
So,
And we can move the numbers to different places too.
okay.
We can move anything. We just have to have, you know, operations between. Okay.
Would you like a clue?
Sure.
All right. Take your first row of numbers with the 13 and move it all the way to the right. That is going to be your answer.
Okay.
Okay? So now, what I'd like you to do is you're going to just think about the operation columns now.
Okay.
All right? And move the operation symbols around.
Can they flip over?
No.
Okay.
I mean, they can, but you don't need
So
to.
up here,
Okay. That's like I didn't know if we had to.
something has to equal to 13. So,
Well, but the equal signs are kind of in different places, so maybe I mean you could.
like, yeah, but our answer has to be 13, I think. Right?
Well, I mean, not. I think not necessarily.
Oh.
I know that's how, kind of what I heard too. I heard him say that's your answer, but
let's-
these don't say equal. Here it would be like that.
Yeah. So,
Just depends on where the equal sign
let's
is.
try 16 plus 5. You know that's 21 minus 2. That's 19. So we can't do that.
Okay.
So move the 2 over there. That over there. So 16 plus 2 is 18. And then we can maybe 18 minus 5. So 18 minus 5 is 13.
Okay. Well, then
So
you
up
would
here?
still need this over here, right?
Yeah, so 13. That's our answer up here.
Okay.
So we figured that out. Now,
But does it work for the other rows? That's the question.
yeah. If it doesn't work for the other rows, then we'll have to find out another way. So 2/3 times 15 equals 10.
So this is division.
Okay, division. So 2 divided by 3, you
Won't
can't
work.
You can't.
So that might actually help us because we
2/3.
know we can only divide certain numbers.
Yeah.
So think about 2/3 times 15. That means 2/3 of 15.
2/3 of 15.
That's true.
You like that way, huh?
2/3 of 15 would be
Is the same as what's 2 times 15
2 times 15 is 30.
and then divided by 3.
30 divided by 3 is 10.
Which is what it says. So that does
Yeah.
work in that sense. Okay. Does this one work?
11 equals 14 plus 7 plus 4. No, it does not work.
So that one doesn't work.
So we have to,
So something's got to change.
Yeah.
But if we change it, it's going to change these two, right?
Yeah.
So we have to strategically change it. Okay, how far off are we on the bottom one?
looks like we're pretty far off already.
Yeah, because it says 8 divided by 6 equals 12 times 9, right?
Yeah.
So, what do you want to move?
I say we move this.
This one?
Yeah.
Okay. All right.
16 minus 2 plus 5. Now 16 minus 2 is 14 plus 5. Plus 5. And 14 plus 5 is 19, so we can't do that. So but we still want the equals up there, so we can't move the equals. That's all we already know. So we can move our numbers.
We can move our numbers.
Did you check all 4 of your rows so far?
Yeah. You mean
Check 'em
on,
again.
on that one? On the one you just had, it didn't work on the top
So,
row.
I don't know. Let's take a look at it.
So 14 plus 5 doesn't equal 13.
All right. So yeah. So all right. So there. Yeah. You're gonna have to switch.
So we knew we had to, yeah, we didn't check them all because we knew.
So here's what I want you to do. Switch your numbers, but instead of switching out the first column, switch the other 2 columns. The 2 middle columns.
2. Okay, and
These
then
two?
Try that way, because we already know the 13 has to be at the end. You want to start with a high number 16 to get to 13.
Okay.
Okay, 16 minus 5 is 11, plus 2 is 13.
Okay, now let's check the other ones. So
2 times 15, and then divided by 3 equals 10. Yep, that's
Okay.
good. Now 11 plus 7, that's 18, equals 14 plus 4.
14 plus 4 is also 18. So that would be 18 equals 18.
Eight-
All right.
18 equals 18.
How about
So-
this one? 12 equals, so what's 8 times 9?
12 equals 8 times 9 divided by 6. So 8 times 9, we already know that's 72. And then do 72
divided by 6.
divided by 6 is,
If you need to, I mean,
um,
you could always divide it out.
So think about 6 times
oh
12.
yeah, 12. That's
Yeah.
12. So yeah,
So it works.
yeah.
There we
So
go.
that works, right?
Yep.
There you go. So you like that kind of problem right there? Mm-hmm. That's a beautiful problem, don't you think?
Yep.
It makes you think a little bit, and there's a lot of different ways that you can do that, but you have to be able to do that in your head and be able to manipulate all those numbers at the same time. Great problem. Glad you had fun with that. Right now, we'll be back with more right after this.
Space Place. In a snap. The solar system we call home has our sun, 8 planets, all their moons, the asteroid belt, and lots of comets. Outside Neptune's orbit is the Kuiper belt, an almost empty ring around the sun that has icy bodies, almost all smaller than Pluto, making slow orbits around the sun. But what's beyond the Kuiper belt? Beyond the fringes of the Kuiper belt is the Oort cloud. Unlike the orbits of the planets and the Kuiper belt, which are pretty flat like a disk, it's a giant spherical shell surrounding the sun, planets, and Kuiper belt objects. Like a big bubble with thick walls around our solar system. It's made of icy pieces of space debris the sizes of mountains and sometimes larger. This is where some comets come from. The Voyager 1 spacecraft took 35 years to leave the sun's magnetic influence. It's traveling 1 million miles each day. At that speed, it will take 300 years to reach the inner layer of the Oort cloud. And then it will take 30,000 to get through it all. It's that thick. Find out more about our solar system and what lies beyond it at NASA Space Place.
All right, a lot of stuff going on with NASA. Do you like space and stuff like that?
Yeah, but also I don't really like the way that like there's like an open, like it's just so huge. Like if you have no astronaut suit on, like and you can't breathe in space, so like it's kind of scary. But at the same time, it's cool because like you can float because there's no gravity.
Yeah, so it would be. I think there's places on
So
Earth.
like
that you'd
there's
actually-
downsides to being in space, but then it would also kind of be fun.
So if they said, you're in 4th grade right now, so you must be around 9, 10 years old, right?
Yep.
And if they said, when you're 20 to 30 years old, we want you to train to be an astronaut, do you think you would do that?
No.
Okay, that's all we need to do right there. No, all right? So you're in 4th grade,
Yep.
all right? And we have 4 4s up there.
Yeah.
Do you have a favorite number between 0 and 10?
my age is 10, so I like 10.
All right, well, that's a good reason why you like 10. So what I'd like you to do is I'd like you to go over to the board and head on over there first and grab a pen. And at the end of that last 4, I want you to write equals 10.
Equals 10.
Now you have to use all 4 of those 4s. And in between each of the 4s, you're going to put an operation symbol like add, subtract, multiply, or divide. And you have to make all 4 of those 4s equal to 10.
Okay.
Do you think you can do it?
Yes.
Do you have any idea what parentheses do in math?
Yeah.
Okay. Do you have any idea what a square root or radical does?
No.
Excellent. What about a factorial? Excellent. So we have room to grow, but we're going to start with the basics first. So you work with Cindy, work with what you know. Add, subtract, multiply, divide, parentheses if you need to. See if you can make the 4 4s equal 10.
All right, so my idea for now is 4 plus 4, and then, so do I put a parentheses there. Do that first, and then 4, and then divide 4, which is 1.
Okay. What are you going to put right here?
Oh.
What kind of math do you want between those 4s?
Plus. And 4 divided by 4 is 1, and 4 plus 4 is 8, and 8 plus 1 is 9. So we can't do that.
All right.
So
There's your eraser if you want to erase.
erase these.
Well, I probably can't do 2 balls at once.
Keep that there, and then do. So we can't do that. So for times 4, we can try that,
Okay.
which is 16. And then right here, I'm gonna try getting
Ooh. Sorry, I just had a.
trying.
I think you're on a good.
I'm trying to
start.
get 6 with these, but I can't because like I'm trying to subtract
Oh, you're right.
that to get 6.
I was thinking a different
to
number.
get 10. So
That's a tough number you chose for yourself, huh? 10?
yeah.
All right, keep working on it.
All right.
You picked it.
So I don't think I can do this one, but I'm gonna try it real quick.
Oh, you keep trying, son. There's
Yeah,
lots of
go ahead.
ways you can do it.
Try. Throw something in there. What do you think? You got 16 so far.
Oh, maybe that's 8. So I can't do that. So to erase that, and then yeah, I'm probably gonna erase
Oh, you wanna erase it?
these. So
Try a different thing.
yeah,
So far you tried a bunch of adding, right? You added, and then I don't remember if you subtracted or not. And you tried some multiplying. Oh, you did a division earlier over there and got a 1, huh?
yeah. So,
Okay, so you got 9, so you were close, but not close enough, right?
I need 10.
Okay.
So
So, Vance, do you know anything about the order of operations?
yes,
What do you know about that?
is that PEMDAS?
Well, some might think that, but tell me what you think. What do you know about that?
Or
Like, what does that stand
I
for?
mean, they do say that, but what does it stand for? Like, what should you do first?
oh, parentheses, exponents, multiplication, division, adding and then subtracting.
Good. So Cindy's going to introduce you to germ-DOS. Right? So instead of just parentheses, we're going to go
There's
group.
an R?
Is this new for you?
I've heard of gyms, but not
Easy now,
germ
sister. Let's
DOS.
go over this all
So
together.
it's
Let's
just you
have a
add
nice
the R
little
for
happy group
grouping.
here, all
All
right?
right.
All right, so we're going to go germ-DOS. Because for every action, you need an opposite, right?
Sure.
So when you have PEMDAS,
Yeah, I know.
right? So you've got your opposites here, right? Those are all the same. But here, right? You know what an exponent is?
An exponent is like put a small little 2 above that 4, and then that's 8.
Yeah, like that, right?
Yeah.
That means 3 times 3 is 9, right?
Yeah.
So you need an opposite of an exponent, which would be a square root of a number. So if I had 9, right? The square root of 9, what number times itself makes 9?
3 times 3.
Right, so the square root of 9 is equal to 3. Grouping means more than just parentheses, right? Because parentheses, you've got that, but then have you ever seen these?
Yeah, they're braces or something, right?
Brackets. Braces
brackets.
have a little more curve on the
Yeah,
inside of them.
brackets.
And then you've got this, which is absolute value. So there's a lot of different ways to group. So that's why PEMDAS is good, but when you want to advance your math, you go to GermDOS. So what I want you to do is I want you to think about the square root of 9 is 3, but we don't have a 9. But we know the square root of 4 is what?
Square root of 4 is 2.
Okay, so use this information. So you're going to put a square root symbol someplace up there because you can make a 4 turn into a 2.
4 turn into a 2, that's going to help a lot. So if
So I
I
guess-
can get 8 with those 2 4s and then turn both of these 4s into a 2, then that would help a lot.
But that'll still be a little bit above because if you make
Yeah.
these be 8, so
How about if you add the first 3 of them? Could you add 3 4s together?
Yeah.
Try that.
Okay.
And put those in parentheses,
all right.
Like the whole thing?
the 3
Yeah,
4s.
all 3 of them.
All right.
And what does that give you?
12.
Keep going.
Ooh, so then what could we do if we made that a square root?
And then do the square root symbol that he
Yeah, it
did.
kind of looks like a division with a check sign on it.
Yeah. And then the square root of 4 equals 2.
So this was 12, you said, and then you'd be subtracting 2. So then you get 10.
Yeah.
Nice. There we go.
There you go. See, it worked out, right? Nicely done. Come on over here. So you are now an ambassador for Do the Math. You have any idea what that means? You know what being an ambassador for something means?
Like a solver?
Kind of, but you're going to tell people about Do the Math.
Yeah.
You can do that for us?
Yeah.
We gave you a uniform, that T-shirt you received, right? So when you wear that, people are going to go, hey, what's that all about? And you can tell them about the Do the Math program, right?
So like it's like the math that you're doing, but then like they had a little twist to it.
Why not? It makes things more interesting, don't you think?
Yeah, it's like more puzzling math. Like
Yeah.
like it's a problem.
Speaking of puzzles, have you ever seen one of these?
Yep.
This is the Do the Math Rubik's Cube. All right, so you get one of those also as an ambassador. Did you learn a little something today?
Yeah.
Good.
A
Did you
lot.
have some fun today?
Yeah.
Good. Well, I'm glad you said you learned a lot, had a lot of fun. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.